Physics 0625, the Math Skills Matrix Code and Exam Strategy. You're about to see the exact patterns behind the repeated exam questions that catch thousands of Cambridge IGCSE students completely off guard every single year. We are tearing down the hidden math skills required for the 0625 syllabus, and I'm going to show you exactly how the examiner sets a 3-move chess trap literally designed to cost you your grade boundary.
The Cambridge Math Skills Grid, the examiner's playbook. Now, what's really crazy is that this grid is the exact matrix code examiners use to set those traps. Directly from the source, this is the examiner's ultimate playbook. It breaks down absolutely every mathematical requirement, from basic number skills like decimals and fractions, all the way up to complex algebra, like setting up equations as mathematical models. And here's the truth. If you aren't filtering your physics knowledge through this exact grid, you're flying blind. It's just not enough to memorize definitions. You've got to know precisely how the examiner expects you to mathematically manipulate them.
Where do most Physics 0625 students instantly lose their grade boundary? Well, we're talking about high-stakes pressure here. A single, easily avoidable mathematical error can and will cost you the grade you deserve. Think about it. You might understand the physics perfectly, right? You know the fundamental laws, you know the theories, inside and out. But the very second you hit those calculation questions, a specific set of tiny, almost invisible math mistakes will drain your crucial method marks straight down to 0. Because the examiner isn't grading your intentions, they are ruthlessly grading your mathematical execution.
Flawed student answer, early rounding and missing units, versus a top-band answer, precise rounding with correct terminology. This right here brilliantly illustrates a super painful learner mistake, falling right into the examiner's trap. Look at a typical flawed answer. The student rounded their numbers way too early in the middle of the calculation and completely missed their final units. Now, it feels like a totally minor slip in the heat of the exam, right? Wrong. In Cambridge Physics, that is fatal. Compare that to a flawless top-band response, precise rounding only at the very absolute end of the problem, with the correct terminology and units explicitly stated. That is the exact difference between an ordinary response and an elite, full-mark execution.
The trap, why ordinary revision fails. So the crucial point we need to take away here is that just memorizing equations, it's not going to cut it if you don't know how to decode the examiner's exact expectations. This is exactly why ordinary revision fails. Honestly, you can highlight your textbook until it literally glows in the dark, but if you don't deeply internalize the specific math skills they are testing, like proper significant figures or rigorous unit consistency, you're walking straight into a trap. The examiner isn't just checking if you remember F equals ma. No, they are testing if you have the mathematical discipline to apply it logically under serious pressure.
1. Concept. 2. Evidence and data. 3. Scientific reasoning. 4. Examiner wording. This builds directly into our high-mark framework, which gives you a massive quick win for structuring every single calculation. To beat the trap, you absolutely must structure your answers logically. Step 1. State the concept or equation clearly using the correct terminology. Step 2. Pull the evidence or data straight from the source or question prompt. Step 3. Apply scientific reasoning, substituting your values correctly without messing up the algebra. And finally, Step 4. Lock it in with examiner wording, making totally sure your final answer matches exactly what the mark scheme demands.
Common chess traps. Missing units, rounding too early, vague explanations, graph axis errors, wrong variables, conclusions not supported by data. These are the fatal errors direct from the source that will tank a promising calculation. You've got to make sure you are checking this list mentally. The source specifically flags missing units, rounding too early, vague explanations, graph axis errors, using the wrong variables, and making conclusions that just aren't supported by the data. Any single one of these is an instant checkmate for your methods marks. Seriously, you need to treat this list like a hazard map every single time you pick up your pen in the exam hall.
In a moment, I'll show you the hidden examiner clue regarding proportionality that changes your final calculation completely. But first, you absolutely need the analytical framework that makes that exact clue completely obvious. So do not lose focus here, because this next part is totally vital for understanding how algebraic manipulation actually works in a high-stakes physics context.
Focus specifically on substitute values of quantities into equations using consistent units. Looking closely at the algebra section of the matrix, this specific requirement is where the examiner sets the ultimate trap for equation rearrangement. The grid explicitly states you must substitute values of quantities into equations using consistent units. Okay, those last 3 words?
They are the tripwire. Students constantly try to rearrange complex formulas in their heads, or they substitute numbers without even checking if they are dealing with meters and kilometers in the exact same breath. And that lack of consistency, that's exactly what ruins the calculation before it even begins.
Interactive challenge. Pause and predict the fatal error in a standard form substitution. I really want you to actively engage with this explainer right now. Mentally calculate the next step and see if you can spot the hidden error in a standard form substitution. Let's say you're given a value in standard form, but the units are mixed up. What happens if you just drop those raw numbers directly into your algebraic equation? Pause for a second. Think about what goes wrong.
Flawed, substituting before converting units, versus improved, converting to consistent units, then substituting into the rearranged algebraic equation. Well, if you caught the error, then you know this brilliantly illustrates the examiner-style correction. You must use consistent units before solving simple algebraic equations. The totally flawed approach is substituting raw numbers before converting the base units. The improved, bulletproof method requires converting everything to consistent SI units first and only then substituting those values into your rearranged algebraic equation. Doing it this way proves to the examiner that you actually understand the physical reality behind the math, which is exactly what the rigorous grading grid demands.
Standard form, scientific notation, and proportionality, setting up simple algebraic equations as mathematical models of physical situations. Okay, let's dive into these definitions because they are essential tools for analyzing data and scoring maximum method marks in harder Cambridge examples. Standard form, or scientific notation, isn't just some neat math trick. It's a fundamental requirement for handling the massive and microscopic scales we see in physics. I mean, from calculating the orbital mass of a planet down to determining the microscopic charge of a single electron, you literally need standard form. And proportionality, recognizing direct relationships like Hooke's law, or inverse relationships like pressure and volume, that is how you set up simple algebraic equations as actual mathematical models of physical situations. Once you realize an equation is basically just a model of reality, spotting the examiner's proportionality clue becomes incredibly intuitive.
Number 1. Now there's exactly one time you should ever round your numbers, and the syllabus states it so clearly. Understand that only the final answer in a calculation should be rounded. One time. That's it. Actually think about it. If you round your intermediate numbers at step 2 of a 4-step calculation, your final answer is going to be completely skewed by compound rounding errors. You will lose the mark. You have to keep the raw, unrounded values safely in your calculator's memory and only apply your significant figures to the absolute final answer at the very bottom of the page.
Practical check requirement. Units must be consistent and present in the final answer. Significant figures. Use decimal places and sig figs appropriately. Reasonableness. Make approximations to check if the answer makes physical sense. Graph scale. Avoid axis errors and ensure data supports the conclusion. Ultimately, you've got to run your final answer through this mental checklist to ensure a total checkmate against the examiner's trap. Ask yourself systematically, are your units consistent and actually present? Did you use decimal places and sig figs appropriately? Did you make approximations to check if your answer is, actually reasonable in the real world? And if you're dealing with graphs, did you avoid axis errors and ensure your conclusion is genuinely supported by the raw data? This checklist is literally your final defense line before you move on to the next page.
The final checkmate. Your flawless math means nothing if you misread the command word. So, we've mastered the math framework, right? But honestly, this creates a completely new unresolved problem. You can have the most flawless mathematical models, perfect standard form, and brilliant unit conversion, but it means absolutely nothing if you misread the command word at the very beginning of the question. How do you decode the exact command words that actually decide your mark band? Because if a question asks you to evaluate, but you only describe, your flawless math simply is not going to save you.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click the video on screen now. Which leaves us with one final, critical question. Are you actually prepared to translate those specific command words into real marks on exam day? To decode the final piece of the examiner's puzzle, you need to click the next explainer on screen right now. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Go master those command words, finish your exam strategy, and discover the deeper code that guarantees you won't leave a single mark behind.